then have Dale, if you don't mind just giving everybody a little bit of background on yourself, and then you can jump into the presentation and educate us.
Sounds good. Let's see. Is my microphone on? Everybody can hear me okay? It's like it's
Yep.
on. Okay, good. Hello, everybody. I'm Dale Richards from App Creative. Guess what we do? We create apps. And we've been in business for about 6 years. And in that time, we've learned a thing or two about building MVPs. And probably a lot of you are here because you are in some way hoping to build an MVP, or you are hoping to render services to companies who are building MVPs. You're wondering how to market MVPs. If you're in marketing, you're wondering how to do a number of things. So by way of background, I got into this business when I opened up a consulting company in 2016. It was a project management consulting company, and then we wanted to build a project management app. We built this app. I formed an offshore team, built it, put it into beta, and then people said like, hey, you built an app. Tell us how you did that. And then, so I told them, and they're like, great, can you build an app for us? And then the next thing I know, completely on accident, I have this software development business. So my company is very accidental. Sometimes you have to go the direction that the market pulls you because the market needs stuff and the market needs you. The question is, what exactly do they need from you? So I just wanted to kind of kick off my introduction with that thought. How to choose the best software architecture for your MVP. I knew nothing about architecture when I built that first app. I had come from an enterprise PMO background, so I had worked with IT stakeholders to build products and things like that. So I knew there, a little bit about environments, and I knew a little bit about coding, but I really didn't know how to put like the whole thing together. And so I want to share with you some things that we've learned since that time. So a quick overview of how software works, and I hope this will be not too basic, but it'll be informative for some people. In today's era of cloud computing, you got code that lives in different places. And in order for you to have the app experiences that you have on your phone or on your computer, in your web browser, there are often different pieces of code that interact with each other in order to create that whole experience. In cloud computing, most of the data lives somewhere on a server. Obviously, Facebook doesn't store all that data for all those people on your phone. That's somewhere in a data center, in a database. But also the logic that accesses the database is part of what we call this backend server or service here. You can see we've got the database over here. We've got the backend software. This is software that runs on a server somewhere in a data center. Okay. And then what you're using on your phone or in your web browser, that's called the client. So there's code that you have for each application that runs on your device, right? And so when you want to log in, the front end of your code calls the back end and says, here are Mike's credentials, give us a token so we can log in and access Mike's account. Okay, Mike now wants to post something to his social media profile. So he writes this post, and then the front end code passes it to the back end, and the back end passes it to the database, and everybody else can see it. That's wonderful. Or Mike wants to refresh his feed, so he sends a request from his phone. So he drags down his screen, the little refresh icon thing spins, and then his screen refreshes. And what has happened is that the mobile device calls the backend server and says, give me all the new stuff for Mike. And then the database returns all that stuff, and then the server serves it back up to the client. All right. Same thing with a web browser, only instead of the code running on your phone, it's actually running on your computer inside your web browser. So that is very, very rude, rough overview of software architecture, right? We've got the front end client code that runs either on your phone or your web browser. We've got the back end code that contains most of the complex business logic that lives in the server. And then we also have a database that's running elsewhere. So any questions so far about some software architecture basics? Okay, now, most of in fact, I don't know if I can even see everything. Like, is there someone, someone watching the chat, just in case I'm not noticing. And we'll also open up the chat messages so I can make sure. Okay, great.
I can let you know when a chat question comes through, and everybody should just feel free to throw any questions or comments in the chat. Thanks, Dale.
Great, super.
A quick question.
Yeah, sure.
Is the back end and the database in the same location, or
The same physical location?
yeah?
They often are, but not necessarily. So you could have like a company that's got distributed content. So there's something called a CDN, or a content distribution network. So for example, you might have your social media data on a server that is in Salt Lake, but also if it's for an app that's running on Amazon or maybe even Facebook, right? They have take that data and then they copy it over to another server that is in, for example, like in Virginia, and then they also copy it over to a server that's in Ireland, and then another server that is in Egypt. And so wherever you are in the world, you're accessing a server that is closer to you, so there's less lag time in getting that data. So content can be distributed, and so you might be accessing content from a number of different locations. If those are kind of some of the big tech giants, right? And so they have special things that they do to distribute content, and also to distribute their backend code. But if you are creating an application for the first time, it's very likely that you will have your server running on one machine, and then you'll have your database running probably somewhere else in the same data center or somewhere close by. That's a good question. Most of what we're going to talk about today concerns this backend section, because there's lots of different ways to run to create a mobile app or to create an MVP. If you have an application, a very simple application that doesn't really require cloud computing, that application could run entirely on your phone. For example, I have a teleprompter app on my phone where most everything that app does is just local to my device, right? I can create a script, I can play that script, it'll play on my screen next to my video camera on my phone, I record it, it saves the video to my phone, and it's done. There's not really a whole lot of cloud computing. Nothing really goes from the phone to a server somewhere or back. Some games could also be like that, except for maybe they might submit your scores to a server somewhere. But most productivity or apps that we use today to communicate, share, to prioritize, or to plan our lives involve some kind of cloud computing where data is stored on a back, in the back end somewhere. So we're going to talk about this back end layer of software architecture. All right, over time, technology has progressed to advance back-end technology. If you recall, like in the 90s and in the 2000s, we had a lot of what we call bare metal. Bare metal is when you actually have the computer, like the server machine, that is in a rack, in a database, in a data center somewhere, right? Now, if you're running software on bare metal, you have to worry about the physical storage of that server. So the actual machine is in a rack, in that rack. So you have to provide a space for that. You have to pay for things like environmental costs, right? You have to maintain the temperature in the data center. So there's a lot of air conditioning that you pay for. You have to pay for utilities like electricity. You also have to pay for things like security. You have to pay for administration, right? Someone has to go in and turn on the computer, and they have to plug it in and hook it up to the network, and they have to set up the operating system. They have to configure it in so many different ways. So that is a kind of a description of running bare metal. Most people don't run bare metal anymore because eventually cloud computing came on the scene where cloud service companies like AWS or Google Cloud started offering virtual machines. So rather than saying like, hey, you got to own your own server, these cloud providers said, you can just kind of rent a virtual machine where we will simulate, we're using more powerful bare metal technology to simulate a server that you can then use to run your code. With virtual machines, you're paying not for all of the physical aspects of the upkeep of that bare metal, you're paying for uptime, right? So the cloud provider is paying for all the bare metal stuff, and then they are marking up that price, and then you're paying for the uptime of your server that's always running.
Dale,
You,
there's a question in the chat about
sure.
that maybe you could address.
I will address the legal aspect of data and data privacy law. I'll do that at the end if you don't mind. That's like kind of a great tangent to go off of, but I want to kind of say that for a little bit. With virtual machines, you are paying for uptime. You're paying for the configuration of those servers, right? So like Amazon gives you a virtual machine and you have to like set up the operating system and kind of tell it what to do, and you have to, you know, script things, and you have to run command line, commands in the command line interface, and to basically get this virtual machine to do what you need it to do. Also, if you have like a lot of traffic, then you have to do load balancing between multiple virtual machines, and that all takes administration. So then after that came along this thing called containers. Containers is more of a recent thing, like within the last 10 years-ish, I want to say. But with containers, it's similar to virtual machines, except that everything is kind of packaged into a module that you can just run and deploy. You're still paying for uptime, but you write it once and then you can just run it anywhere. So if you have like one virtual machine, you've deployed this container to that machine and you need another virtual machine, rather than having to like set up the second machine and then configure it. And what you just do is you just say like, okay, we're going to push this container to that machine, and then bam, everything is like kind of pre-conditioned, ready to go. So it's more portable, it's more modular. So it reduces the burden of administration. It makes it easy to spin up new servers if you need them. You still have a load balancing issue, so you still have to kind of manage like, okay, do we have enough servers? What happens if we have so much traffic that the current containers that we have running, if they're overloaded, we have to add some more. So there is still some administration, there's still some load balancing you have to do, but generally it is more easily reproducible than virtual machines. Then, more recently on the scene has come what we call serverless functions. In serverless, what happens is that rather than paying for physical storage and maintenance, rather than paying for uptime, what you're doing is you're taking a bit of your code, your business logic, and you're putting it inside this thing called a serverless function. And then what happens is that the front end calls that function and says, hey, Mike needs his login token. And then the function gets triggered by this trigger event of the front end calling it. And so then the actual computer that's running, the server that's running this function, spins up the function, executes it, and then shuts it back down. So it's triggered by the front end. It spins up, executes, shuts back down, and also it can auto scale. So it really doesn't matter how many, like you don't have virtual machines running. So it really doesn't matter how many people call to trigger that particular function. When it gets triggered, it runs as many times as possible. So you're really taking the pain of scaling your your traffic, and you're handing that pain off to the cloud provider like AWS or Google Cloud or Azure. So those parties are the ones now that just scale automatically your code, which is great. You don't have to worry about a load balancing and how many machines you have, because those are not part of the equation. So you only pay for the computing power that you actually use. You're not paying for uptime. If you rewind a little bit, with virtual machines or containers, you could be paying for these machines to be running all the time. But if like you are kind of in a low season when not as many people are using your app, you don't save money just because people are not using your app as much. Well, with serverless, you do save money, because with less traffic is less computing power, and with less computing power is less cost. All right, questions so far about the progression of backend technology? Okay, all right. So now the question is, what do I do if I'm trying to launch an MVP? So with let's go back a little bit. Oh gosh, I gotta go all the way back here. Okay. With this backend, your backend code can be monolithic, meaning it can be like one single chunk of code that takes care of all of your requests. So if you're building a really simple MVP, you could build a monolith that basically one chunk of code is running on the server all the time, and people call that monolith, and that monolith handles all the requests from logging in to posting an update to getting the news feed, or like all of the different requests that happen happen through that monolith. So I'll give you an example. We made an application called Fire Tribes, and it was this kind of cool vision board hypnosis application. So you would put your you would like kind of create a goal, and you would associate like a trigger word with that goal, and you would upload an image, like a photo with that goal that would, that you could attach to that goal. And then also you would write a manifest statement for that goal. And then you would also record your voice saying that manifest statement. And then what the app did is it kind of played through or concatenated all of these different statements, and put some kind of cool beach sounds and hypnosis music in the background. So it could play through all of your vision board manifest statements, and you could listen to this and kind of feel like, yes, this is what's happening to me this year. So it was a really, really cool application. The thing is that it's a monolith, so that chunk of code that was on the back end did everything. It logged people in. It created new goals. It uploaded images to those goals. It received the audio files from the front end and stored those audio files. Now, the problem with a monolith, I'm going to move back forward here through my slides here. The problem with a monolith, where all of the code is one big chunk of code, is that if that server, that virtual machine where that code is running, if it goes down, your whole application is unusable. No one can use it. And so there are some pros and cons there. Monoliths are less expensive to make. If you are building simple products, if you're bootstrapping and you have limited budget, you're trying to prove a concept and you don't need to scale it and put hundreds of thousands of users on it, a monolith can be great. So that's a monolith. But as you use serverless functions, and you're breaking out all of your business logic by function, right? So you have like a service for logging in, a service for creating a goal, and a service for uploading a photo, and a service for recording an audio. If one of those goes down, it's not the end of the world, because people can still use the rest of your app. You probably noticed that if you're using Instagram or Facebook, if a certain aspect, like let's say marketplace, Facebook Marketplace has some, you're not able to post a new item to your Facebook Marketplace because maybe that one specific service for posting a new item is having problems and they need to fix it, or there's some kind of a little bug. Well, the rest of Facebook still works. If Facebook were operating on a monolith, you wouldn't be able to do that. And also the performance for Facebook would be so bad because it would be such a big chunk of code, because Facebook has so many different features that it has so many different services. So what Facebook has done is they've broken those down into these into these little microservices, because there are enough people that need to use each service. So a monolith where you're running that on a virtual machine is great for the bootstrapping entrepreneur who has a limited budget and is just trying to get a concept out there to prove it. But that'll only take you so far. Let's say that you take your MVP to market and people start using it and they find value in your value proposition. So people start signing up, they start subscribing, they get access to your application. And then you've got like thousands and thousands of requests hitting your little virtual machine with your monolith on it every day. And pretty soon you start to get timeouts, like that server becomes overloaded. So you have to add a second server, etc. You can only fly so many people on the Wright brothers little airplane. At some point, you're going to have a more robust architecture that's going to serve more people, more traffic, and more load. And that's where a serverless comes in, because you don't have the headaches of scaling like you would have if you built a monolith. So the ideal progression in my mind is, depending upon how simple your product is, you want to start with a monolith if you're bootstrapping and paying out of pocket. You launch that product, you market it, you're refining your product, you get your sales going. And then as load increases, then you start to take chunks of that monolith and you break those out into separate services, and you make those serverless so that they'll scale automatically. And before you know it, you've transitioned from your monolith to your serverless microservice architecture. We have had clients that are bigger enterprise clients where they already have validated the concept, like they have enough data to say like, hey, we know that this product that there's a need for this in this market, we're going to go straight to a serverless architecture. And for them, that's an MVP. It's just an MVP that has a much bigger budget and a much more robust architecture. So let me give you an example. This client specifically was a real estate SaaS client. So they're already operating, already have multiple other products in their portfolio. They wanted to create this new product. They wanted it to scale using this serverless architecture. And so also the architecture was necessary because they had multiple data sources coming from different places, like mortgage data, insurance data, market data, just different things like that. And so the architecture had to be more granular and it had to scale out right away. And so they went straight to the serverless model, but also the budget was a lot bigger. So an MVP in terms of cost and size and scale is going to vary based upon you and your needs. The thing about it is that the monolith is much less expensive to build. Here's kind of an example, a demonstrative cost comparison. If you have a monolith, you can continue operating your monolith. If you've already built it out, you're going to pay for your monthly computing costs and your maintenance costs, et cetera. And then, over so many, let's say that you're going to own that product for, you're going to own that product for 5 years. Well, every year you're going to have just operating costs. Those operating costs could be lower if you were to rebuild it using serverless, but also at the same time, the build out costs something. So you have to be cognizant of how much does it cost to build this up front versus how much does it cost to operate? Is it serving our people, serving our users, serving our load and our traffic needs? Those are all questions to consider when building out your MVP. All right, that is a very brief overview to serverless technology and what's going on in the backend architecture world. Are there any questions? Let me go back and look up at the chat. The comment that Tyler made was about there are legal reasons why a database might be in a particular country. Yes, absolutely. If you're, let's say, for example, if your users are in Europe, you may not transmit that data, the user data, to the United States, for example. They have different legal privacy laws. Or if your users are in Russia, then the same thing. Like you can't. Those countries may require you to store the data of their citizens on a server in their country. So that's always a legal issue. I think that it does have an impact on architecture in terms of where servers are located, but you could have a monolith operating in Russia with user data being stored on a database in Russia, but you also could have serverless running in Russia, right? You could have the German serverless app, you could have a German monolith. So you could do it, you could use either architecture in a country like that. That's a really helpful color for Tyler to add. Thank you very much, Tyler. What is the size of the app that lives on the client device? That is a very insightful question, Harley. Thank you. I think actually, if you go to if you're on an iPhone, you can search for storage, and you can, and under settings, there's storage general, and then you can see the app size for just about most of the apps I want to say. It kind of takes a while to calculate, but some of those apps are in the tens of megabytes. Some of them are in the hundreds of megabytes. And also then you have to be careful that you're distinguishing between the application itself and the data the application uses. If you scroll down, for example, if I'm on my phone and I'm looking at Facebook under storage, it will show me that the app size is 299.2 megabytes and that the documents and data that I have downloaded from the application are 456 megabytes. So, and you can do that similar thing for all the rest of these applications. LinkedIn, the actual application itself on your phone is 327 megabytes, and the documents and data are in addition to that. So that's about how big the binaries are, the actual code that's running on your phone. And as you scroll down, you can kind of, the iPhone storage screen and settings will sort those applications in descending order by memory, by storage capacity that is used. So you scroll down to the bottom and you get smaller apps. For example, the NPR app from National Public Radio is only 34 megabytes. So not a very large application at all. If you look at, for example, VIP access by Semantic Enterprise, right? That's like a security, that's a pretty simple application deploying 9.2 megabytes. So I hope that answers your question, Harley. Peter asks, you mentioned the downsides of the monolith. What are the downsides of microservices architecture? So the downsides, thank you for asking that question. I probably am evangelizing microservices without really giving airtime to some of the cons of microservices. A microservice architecture is more of an enterprise architecture. You need to be more attentive to making sure that each service is up and running. So if you have a monolith and you can see the status of that monolith, is that server, is it running or is it down? Well, when you have microservices, then you have to do that for each individual service. If you're running each service on its own virtual machine, which you could do. That's what's great about serverless. You don't have to worry about the uptime or the downtime because you're not paying for uptime or you're not paying for uptime. What you do need to then pay attention to is the performance of each Lambda. So if you call the serverless function, it does take time. It spins up, executes, and spins back down. Sometimes they have what's called like a warm-up call. So like they kind of get the Lambda spinning and running so that as soon as it finishes serving one customer, it serves the next customer. So the length of time it takes to execute a serverless function once will require attention, but it will require less attention. In the aggregate, the goal is to have automated performance where once you optimize for speed performance, that you kind of just set it and forget it, or rather you can automate the performance metrics so that you can see reports on how well your serverless functions are performing. But that's one of the great things about the microservices serverless architecture, is that so much of that can be automated and the performance is automated that it requires much less attention. Okay, all right. Shay asks,
we've got
yes.
for probably these two questions in the chat, then any other comments that you want to share. This has been
Sure.
awesome. Thank you.
Super. Shay asks, is there a meaningful difference in turnaround time between monolith and microservices architectures? Yes. Depending upon how much logic there is to build. If you are building a monolith, it's likely because the actual application is simpler, but you still are going to spend probably between 3 to 6 months in building that out. With microservices and serverless microservices, you're probably going to be spending more like a year building things out. And also, it's important to recognize that some enterprises have multiple products that are all kind of interdependent. So we have a final mile logistics client right now where we have a set of backend serverless microservices that serve like retail B2B transactions, right? So let's say Zara wants to push deliveries out through this client's drivers. And so Zara then has like an API where they make a call to the Lambdas that we built for the client and just put orders to them so that the drivers can pick up the orders and go and deliver them. So that's like one set of retail B2B endpoints. And then we have like another set for the driver application to use, and then another set for like the admin portal to use. So there's multiple products, so that like just more stuff in general. So I would say that there is going to be additional time to build serverless functions, but you also have to account for, bigger products require more work anyway, and so I think there's probably maybe like a 30% gain in doing it in a serverless way. Let's see. Okay, so from those yearly costs of running an app and the cost of starting one, is it an accurate assumption to say that if your MVP is not going to bring in more money than it costs, then it's not worth pursuing? Yes, I think that's a pretty good conclusion. I feel there surely are some apps that are not bringing in anywhere near those startup and run costs. That is definitely true. I think that's, Taylor, that's a great topic for an entirely separate Midday Connect, because there we're really talking about go-to-market strategy, and we're taking the market risk and the execution, like the technical delivery risk, and we're looking at that portion where those two overlap, right? And if your app is not going to bring in more than the costs, then absolutely you don't want to destroy value. Unfortunately, that happens all the time. You know, I was having lunch with an incubator VC in November, and he was telling me, yeah, it's really kind of sad because we see a lot of tech startups that they don't have market fit. They spend money building products, and then those products don't perform well on the market, so they don't bring in enough money to sustain themselves, and then those products die. So yeah, that is definitely a concern. Harley asks, how are permissions controlled? That's a great question. I'll tell you how they're controlled in AWS specifically. AWS has a whole bunch of different web services that they offer. One of those is the Lambda, right? The serverless function. They also have a service called Cognito, which is their identity management service. So what happens is that the front end calls the API gateway, hits the specific Lambda function with your business code in it, and then that if there's authentication that happens, it goes via this Cognito user profile, if you will. So the permissions for those users are controlled via the Cognito service. That's not something that we've mentioned here, just because we're starting to get into other detail about architecture and
right. I think you answered the question. I was just wondering how hackable it was and whether the app lived on the SIM card or in RAM.
Yeah, with Amazon Cognito, it's great because you're transferring a lot of the security risk to AWS, because they like cloud providers like Amazon and AWS and Google, like they're really looking to advance computing and cloud computing. And so you're really benefiting from all of the innovation investments that they're making. And that's one of the nice things about using a service like Cognito, is because now you're getting the top of the line user profile management and security protection. Let's see. Oh, there's some back and forth with Tyler and Randy. That's awesome. No code solutions can be used to find your product market fit. Yes, actually, I don't want to take away anything from Midday Connect. We're having a webinar about that on the 1st of February about no code solutions. So if you want to learn more about that, you can check us out. You can go to my LinkedIn profile and see that webinar that was just posted yesterday.
That's awesome, Dale. I would say if you have a link or something, you can put that in the chat. I would invite everybody who's interested to head over there. That would be really cool.
Yeah, let me do that. I don't want to maybe after all of the app building, I'm sensitive to like taking Apple users away from the App Store, and so that's kind of you kind of want to honor the channels that you go through. But if you're okay with it, I'm going to paste this event URL here in the chat. So if you're interested in hearing about low code with me and my friend Imran, you can join us on February the 1st. That's a Wednesday at noon Mountain Time.
That would be awesome. No, we're all for that type of thing. And I would suggest maybe, Hannah, that could be a post for the Midday Connect on LinkedIn, is just sending people Dale's way. It's really, we're very sharing here. So anything we can do to help get the word out, Dale, let us know. This has been awesome. We've kind of hit our time limit, but Dale, thanks so much for your time today and sharing this. Would you be willing to share your presentation? Hannah could send that out to the attendees if you're willing to do that.
Sure, I will export a PDF and send it to Hannah.
Okay.
Great.